So electric circuit question 19, figure 8.1 shows a 240 volt main supply. So this is and there's an air conditioning unit. So as they are in parallel, and we assume that there's no voltage drop across the fuse, so the freezer and the air conditioning unit both will receive 240 because they are in parallel to the main supply. A fuse X is placed in the circuit as shown. The freezer has an operating power of 700. So we have the power of the heater, calculate the current. So, and we have the voltage as well because they all are in parallel. So they with the main supply, so they will receive the same voltage. So we will use a formula P is equals to VI. So power is equals to 700, voltage is 240 and current we don't know. This will be divided to 700 divided by 240. What's the answer for the current?
2.9.
So 2.9 ampere will be the current. And so how we work out that it's a 240 volt across each of them because they are all connected in parallel to the supply. Then the maximum operating current of air conditioning unit is 7.5. Fuse of current rating, like we have a fuse of 1 ampere, 3 ampere, 5 amperes, 10 amperes, 13 ampere and 30 amperes. Suggest a suitable rating of a fuse X and give two reasons. So first what we'll do as we work out the current in the freezer, how much current it was 2.9 ampere. And they mentioned the air conditioning unit, maximum current like the current which is there in air conditioning unit, that is 7.5. So what is the total current entering from the supply? Because in parallel, the total current will divide in the branches. So what is the current coming or from the supply? That will be equal to 7.5 plus 2.1 because 7.5 and 2.1 will join. So that's equal to 10.4. So 10.4 is the maximum current we need for these air conditioning unit and the freezer to work. If the current is less than that, it won't be efficient. So whenever we are selecting a fuse, we always select a bit more than that. Like example, if we want, for example, we want 10.4, so we select a fuse rating with a more than 10.4. So what are the options which are more than 10.4? So these all options are not valid. Why they are not valid? Because the maximum current we need is 10.4 ampere. If I select a 1 ampere fuse, it will melt 3 ampere, will melt 5, will melt 10, will melt. So we are left with two options, 13 or 30. So which one I should select? So I should select 13 ampere because like 30 will be too large. So reason, what will happen if the current, why we select this one? If like example, if too low, it will break or blow, it will melt. And if too high is there, it will be dangerous. So why we did not select, why we specifically select 13, why not less than 13? So that we have to mention a reason here. When they ask what is the purpose of a fuse, purpose of the fuse is to limit the or disconnect the circuit when the current is above the required value or a rating of a fuse. The main purpose of a fuse is to disconnect a circuit or protect the device to carry too high current. So here we select 13 ampere and reason one, because why we did not select smaller than 13 ampere? The fuse will melt. And why we did not select larger than 13 ampere? It will be dangerous or it will affect the device or can damage the device or appliance. So that 13 is a suitable number according to the current of 10.4. Why not less than 10.4? Because what will happen? The fuse will melt if the current is less than. Why we select a fuse less than 10.4? Because in the supply, from a supply, it's 10.4. If I select 1 ampere, 3 ampere, 5 ampere, or 10 ampere, the fuse will melt. And why I did not select 30 ampere? that will be too large, so it can even damage the device or it might be dangerous, you can mention. Is it clear, this one?
Yes, sir, clear.
Then in part C, a fuse is made out of a short length of a wire. Explain why fuse of a high rating are made of thicker wires. So fuse of high rating means the fuse which are allowing greater amount of a current, because a fuse is made out of a short length of a wire. Usually, fuse is not very long wire; it's a short wire. But if we want a high current, like example, if you want 13 ampere to pass, we want 30 ampere to pass, the fuse, the wire should be thick. So why the wire should be thick? What is the effect of the area or the thickness? Resistance and area are inversely proportional. As the area increases, the resistance will decrease. If the resistance decreases, the current in the circuit will be more. So as a result, what it need like a heating effect, depends on the, like it can allow greater amount of a current to pass before it melt. So when we use a thick wire, the thick wire resistance is inversely proportional to area. The thick wire will have low resistance. If it will have low resistance, it will allow greater amount of a current to pass. So as it allow greater amount of a current to pass through, what will happen? Produce, like it need a greater amount of heating or produce a greater heating effect to melt the wire. Is it clear, this one, the last part?